Hi everyone, and welcome to the March edition of the London React Native Meetup. This is our first ever online edition of the Meetup, so hopefully everything goes smoothly, and thank you for watching the first ever online live edition. Thank you very much as well to Pusher for being able to live stream it for us at such short notice, and as always, all the talks after this will be up on their channel. As always tonight, we've got two great talks coming up. The first by Mike on MobX state management. MobX is an alternative to Redux, and he's going to talk us through with some live coding, how to use MobX and how to reduce your boilerplate using MobX. The next talk will be by Cam and Hentie, and it will be about building a web-like workflow for React Native. They're going to talk about some of their experience at Kantan on using web deployment tools and how they've managed to reap the benefits of those in React Native with a React Native deployment and integration pipeline. As always, we are looking for any speakers for upcoming months, both in person and online. Well, hopefully in person if we can. But the link to sign up to speak is on the Meetup page, so head there if you'd like to speak in the future. But without any real further ado, let's go into the first talk by Mike.
Hello and welcome. This is Mike. I'm a software engineer based in London, United Kingdom. And today I'm going to talk about state management in React and React Native. And mainly I'm going to talk about a library called MobX, which really simplifies state management. And unlike Redux, it requires you very little boilerplate code. And with MobX, we've been successfully using it at my company for a couple of years. And we have developed a fintech mobile app with that, and it worked marvelously well. And we also have a web app which predates it. And the funny thing is that web app is written in Redux, and every time I have to do any work in it, I really miss MobX and how concise it is. And before I start talking about what MobX is, just a few points about Redux and why I think there are a few problems with it. Just a couple of days ago, I stumbled upon this tweet, and I really resonate with it, and I'm sure my colleagues would also concur that Redux is great for extracting your state out of components, but then the code which manages the state ends up in a very different places. Because if you think about it, the usual architecture for using Redux is something like that. You have a component which at some point triggers an action creator, which dispatches an action, which then goes into reducer, and finally that re-renders your component. So in this session, when we'll do some live coding, we'll take a simple app written in Redux, we'll see the problem, and we'll see how MobX will make it much more concise. And MobX relies on the observer pattern, and that means it's not afraid to mutate the state. And that really results in how concise the code is for managing your state. Similarly, MobX stores are also a great place for putting your business logic. And it also allows you to easily unit test it. And a funny trivia is that the creator of MobX is now working for Facebook, so I think it enjoys some support in the community. And at this stage, we'll proceed to some live coding. I'm going to demonstrate you a simple app I created with React and Redux. It's another to-do app. It shows to-do items, and it allows you to add a new one. For example, we can add an item called convert it to MobX, and it will appear on our screen. The key thing about this app, it doesn't store data in memory. It actually sends calls to a web server, which returns this list of items and accepts new ones. The reason for that, I wanted to make this example a bit more real, because often we do need to make HTTP calls, and I think this is important to understand how you can work with that when you're choosing a state management library. Now, if you dive into the code, we will see that we have two components on the same level, which you just saw on the screen. One of them is for adding new to-do items, and the other one lists all the to-do items we have. And that really highlights a necessity for having state management, because we have those sibling components which do need to exchange data. And if you look at new to do, it's like a pretty simple component where we display an input item and allow adding a new one via a Redux action creator. And similarly, the component which lists to-do items, what it's got. When we render it, it calls use effect to get to-dos, which is another Redux action creator, and then it gives properties with to-do items, which it displays on the screen. So component-wise, it's nice and easy. It's just mostly pure React with a few React Redux high-level, high-order components, which provide us Redux plumbing. But if you look into how our Redux store is structured, that's where the things get a little bit more verbose. First of all, we can see where create a store. We have one file. It gets reducer to dos, and because we use HTTP calls, it also has to apply a middleware func to enable asynchronous action creators. And here we are. We have action creators. Once again, the code is not particularly complicated, right? When it comes to getting to do, we send an HTTP request, we wait for it, then we dispatch an action. And when we do to do, we do similar thing, but we call the existing action creator. And then we have reducers, which create a new state. And finally, we have constants, which define the action names. And this is the model which has to be shared between action creators and reducers to know that we are talking about the same action. So to summarize, although all those bits like reducers and action creators are not particularly complicated on their own, if we combine them, we'll see that we add this big verbosity to our code. And sometimes it becomes a little bit complicated to see what's going on where. And right now, having said that, I'm going to demonstrate to you how we can replace this pretty verbose code of Redux with something more concise done with MobX. So let's start. What I'm going to do, I'm going to delete the contents of store.js file, and I'm going to start writing a MobX store. So typically in MobX, we use classes. And I'm going to create a class called to-do store. And in that class, we're going to define a property called to-dos, and it's going to be an empty array, and it'll hold our to-do items, and we're going to decorate it with observable, which is one of the key concepts of MobX. What observable is, it allows us to decorate this property or even a variable. It doesn't even have to belong to a class. And every time there is a change to that variable or property, it will notify all the observers, which are going to be React components, and it will re-render them. So having defined a variable which will hold all data, our next step is to define actions which will perform manipulations on the data. And as we have seen before with our Redux example, there are actually two actions here: retrieving data and updating it. So let's start with retrieving data. We're going to define a method called getToDo's. It's going to be a MobX action. And it's also going to be an asynchronous method because we're making an HTTP call and we use async await for that. So similar to Redux, it's going to be actually that simple. We're going to use fetch to get data from the API, and I need to put await here, and then we need to get JSON data from it. So we do await result JSON, and finally we assign the result to our to-dos. So this is really simple. We just created an action which performs something, in this case fetching data from an API, and it assigns to our variable which is marked as observable. So when we start looking at components, you will see how they'll get re-rendered. And quickly, I'm going to do the same thing for adding a new to-do item. So as you can imagine, we just need to create another method which is going to be decorated with action, and put up to-do, which will accept an argument of to-do item. And similarly, we also need to perform a fetch operation. In this instance, it's going to be a post request because we added a new item. Body is to do, and once it's completed, we are going to refresh our to-dos because we want to make sure that our entire front end is driven by the backend, so that they're all at the same state. Okay, so this is basically it when it comes to defining your stores. Just one single file, just one single class, and just like 20 lines of code, which define our data, mark it as observable, and define actions which allow us to perform certain things on the data. So far so good, right? Another thing we need to do is to look at our components and see if they require any changes. So let's start with a to-do component. So you will see that, as I demonstrated you before, this component does two things. On use effect, it calls getToDo's, and then it just displays a list of items. So the only thing we need to change here is, instead of getting to this properties and method called getToDo's, this component as a property will get a to-do store, and we're gonna call to-do getToDo's and to-do store. And similarly, to-dos are gonna be on to-do store, right? That's cool. We won't need map state pros and map dispatch pros. And what this component will need is it will have to become an observer, which, as I said before, is a MobX concept. We have observables, which our data, we perform different actions on, and we have observers, which react on changes in the data. So I'm going to import it from MobX React. And it's almost that. Of course, you may wonder where this property to do store will come from. Similar to Redux, there will be another higher order component provided by the function called inject, which will inject the stores into our component. It's got like the syntax. It maps actually a number of different stores. In our example, there is just one store called to do, and it maps it onto a list of properties. VS Code says I've got a syntax error somewhere. I think, yeah, that's because inject returns a function, which allows me to wrap my observer. And with the simple manipulations, we have changed our to-dos component to use MobX. It's very tempting to go and run the code right now, but chances are it's going to fail. So we need to do two more things. We're going to do the same for our new to-do component, which will even be easier. And then we'll change the wiring and the provider. So with the new to-do component, as you can imagine, the first thing we need to do is to inject the store and modify what happens when you click on the button. We're going to call to-do store at to-do. Our map dispatch the pros will disappear, and what we're going to export is going to be even simpler. In this instance, new to-do doesn't even have to be a MobX observer, because this component does not have to re-render on changes. So the only thing we need to do is just inject the store into it. So new to the store, and we'll map all our MobX stores onto properties of this component, and we'll wrap it in it. And now we just need to remove all these imports. An interesting thing is even our import statements become more concise and just import inject from MobX React. Right, so we have ported another component onto MobX. So as I said, the final thing is to do a bit of plumbing, and it's going to be very similar. So what I haven't shown you before, but you may guess, right? So somewhere there is a file where we wrap our entire application inside the provider, which injects the Redux store. So we're going to do exactly the same thing with MobX. Instead of importing provider from Redux React, I will do it for MobX React. And similar like I did before, I'm just gonna to-do store is new to-do store. And to-do store lives in store/store. So far, let's just go and test it. And I'm just gonna cross my fingers that I have not messed something up. Okay, to-do's inject is not defined, to-do is not defined. Okay, demo gremlins. Yes, I have forgot to import inject. And to do is not defined in todo's JSX. Which line? Okay, here I made the top typo. Okay, it is todo's. Boom. By mail, call set agent converted to MobX. What the new item? Record a video. Excellent. Okay, probably I should change the title into to do Redux to do MobX. So within literally 5-10 minutes, what we did, we've taken a small Redux application and we converted into MobX, and I think that really allowed us to reuse most of our components like to-dos and new to-do, make some little changes when it comes to how we wire things, and write our store, which is like far more concise now that we have like a single class with just like 2 methods as opposed to action creator, action reducers, and 1 observable. And now I can safely delete other files of Redux and see that my app still works, and maybe add another to-do item, which is have breakfast, because I'm recording this video early in the morning and it still works. Another thing I just want to point out, like I was talking before, in terms of observables and observers. So our data is observable and our components are observers. And so what it means, to-do is a good example. So if inside our observer, we access our observable, like in this case, to-dos, every time to-dos will change, MobX will automatically notify all observers and it will trigger re-render. So nice and easy. MobX does the heavy lifting for us. Okay, so if you're interested in seeing that code, it's available on GitHub. There is an example of Redux application, and there is an example of the MobX application, plus the Node.js server, which serves data, so you can see it for yourself, you can play it with yourself. And I just want to highlight once again the work we've done, right? So if you have a look at the Redux store, even if you combine it in the single file, it will be still quite verbose in comparison to what we see on the left-hand side with MobX. And I think with Redux, personally, it's not just verbose, but sometimes a bit difficult to see what things are doing. Like we have action creators, we have reducers, and MobX is far more concise. And if you just look at components side by side, you will see that our render function hasn't dramatically changed. Like what changed is the properties we injected, and we could actually do it even in the same way as in Redux to inject properties which hold data and functions and which perform actions. And instead of doing map dispatch to prod, we do observer and inject. Some of you may wonder about hooks. And in this instance, I'm not talking about use effect and use states, because we have already used them. But recently, React introduced hooks such as use selector and use dispatch, which replace map dispatch to props and map state to props. So easy. MobX actually has similar mechanism. You can use hooks instead of wrapping your components inside inject. In my personal opinion, it couples your components too much to a state management library, so that if you right now, your components will have knowledge of that through hooks as opposed to getting information through properties. In my opinion, if you do unit testing of your components, that will make it slightly more awkward, because instead of just passing correct properties, you'll have to mock your hooks I mean, which is doable, but in my opinion, not the best way. But really, it's up to you. MobX doesn't mandate anything here. Another thing I wanted to highlight, I didn't show it in the demo. So MobX has a number of other cool features. Like, for example, what you see on the screen, and that's taken from the official documentation. So you may have defined for your online shop something, an observable called price and amount. But equally, you may have architecture your application in a way that there is a component which just displays total price, right? So that component doesn't really care about the price of each item or like, an amount. So easy. You can define compute properties, and they will trigger re-render of those components which depend on total every time one of the components of the formula changes. That's actually, as the official documentation says, quite similar to formulas in Excel. And I just prepared a list of possible questions I may get. And one of them is, can you have multiple stores? Easy. In MobX, you can define as many stores as you want. For example, in the applications we are currently working, we have around, 10 or 15 different stores for different features. Another question, does it work with React Native? Of course. And actually, this is React Native meetup, although I showed the React Web, but it works with React Native fantastically well, and we do it. Has it got debug tools similar to Redux? Yes, it does, and they work quite well. You may all have also seen that we used EM as decorators, like at observable. The question is, do you have to use them? Actually, no, you can just use functions which will wrap your variables or properties. I think decorators are just a nice syntactic sugar which makes it more concise. Now, does it work with any kind of components? So it works with functional components, as you have seen, and it works with big fat components, React components. It doesn't do it with pure components though, because of issue with should component update. And so guys, that's it. Thank you for listening. If you have any questions, please ask them on Slack or in YouTube comments, and feel free to follow me on Twitter and chase me up with more questions. That's it. Thank you guys. Bye.
There, Mike. If anyone has any questions, just leave them in the chat and we'll get these to Mike. But first of all, I've got one for myself. So as any developer, there's often a lot of bugs in the code that I write. But how is debugging in MobX compared to in Redux?
So I think it is pretty good. So as I mentioned, there are debug tools. If I remember correctly, there is a Chrome extension which allows you to inspect your stores in a similar way as Redux does. Frankly speaking, I had some issues with connecting it to React Native, but then there are also inspect tools which allow you to print your entire store at different states into Chrome console, and it was actually really useful in smashing one of the bugs we had recently.
Okay, then, so
another thing which I think really assists you debugging is, once again, that MobX is very concise. Because very often, if I have to debug a Redux application, I end up putting breakpoints in action creators than in reducers, because I simply don't know where the problem can lie in. And the good thing about MobX, like, your code is much smaller. So chances are, if you have any issue, it's going to be in your actions.
Okay, Thank you very much for that. So we did have one question through from Alexandru, who asked, what are your thoughts on MobX versus MobX state tree? Is it something you've used?
So frankly, no. I literally I heard about it a few days ago, and I just did some googling on being on video, and it's interesting. I need to look in it more, but frankly, I haven't used it.
Okay, so we've got a question coming in here from Christian. Nice to see you in the stream. It's, can you observe actions in MobX and not just state? I.e., can I have something receive each call to add to do like I would with sagas or middleware?
So if I understand correctly, the question is, can you also invoke additional actions every time we get a code to add to do? Yes, MobX has a thing called reactions, which allow you to have additional side effects when something changes. There are also interesting things which are called when, so you can also define when such reactions can happen. Like, for example, if you value miss a certain threshold, it's pretty interesting. Like, I suggest you look at MobX documentation into those things.
Okay, that sounds great. The next question comes from Martin. It is, what is the level of support for mobs in MobX and debugger, I assume? Is there a plugin for Chrome? Does a React Native debugger support it? So I think that's pretty much exactly what you've just said before.
Yeah. I think like just for React Native debugger, I had some issues with the Chrome extension, but then again, you enable debugging in one of the MobX settings, and then you see entire print out in your Chrome console.
Great. I suppose one of the other questions I have then is, I've heard there's some people find it less scalable at larger levels than something like Redux. Have you had any issues with scaling?
Personally, no, but I think we should also define what we mean by scaling. Are we talking about large volumes of data? Are we talking about a large number of actions, or just a big application in terms of the code base and complexity?
I was talking about possibly the having a large number of states kind of in an impure state can often, people find it a bit less maintainable and I guess a little bit harder to use. I guess it's code complexity and code size if you have quite a complex state.
So that's interesting because so in our application we have I think around 15 different stores. So frankly, we don't have that problem, but I guess it also depends on how you structure your code. Because the way we try to do that is to provide a MobX store for each feature. But then again, we also try to revisit it. If you see that one of our stores is becoming too complex and it ends up having too many responsibilities, we always split it. So the good thing is you just can apply usual programming principles.
Okay, that sounds excellent. Well, thank you very much for the talk again, Mike, and thank you very much for answering the questions. I might consider using MobX in the next project.
Thank you.
And now into Cam and Hentie's talk.
Hey everyone, thanks for joining. This will be a quick look at deployment pipeline we built at Kantan and how we implemented previews for deployment previews for React Native. So just to introduce myself, I'm Hentie. I'm a software engineer at Kantan. And you?
I'm Cam. I'm an architect developer at Theodo UK. So a little bit about Theodo. So we're a startup that helps other startups build digital products. And we worked with Kantan for the initial MVP phase to build their app and also lay the foundations for the current phase that they're working on.
And what Kantan are doing, what we are doing as a company is we're helping trades professionals work smarter. That's the tagline. That's our mission of what we're trying to do. And the way we're doing this is through building an app. And this is an app for gas engineers and electricians and plumbers and that sort of thing, to help them to automate some of the tasks they do manually. So they spend a lot of time doing these manual tasks, and we just help them to do that more easily. And would be things like scheduling their jobs and sending notifications to customers.
So Kantan have a big vision for the sort of stuff that they're trying to build. So a bit more context on the kind of technology that we were using behind the product. So we're using React Native, obviously, TypeScript, GraphQL, and we're using App Center and Code Push for deployments.
So when we first built the app, the initial pipeline we came up with is something like this. When code is merged to master, we run the tests, which are like jest tests, UI tests, like Detox, and then we do a deployment of the code. There's like a native deployment to App Center and a code push deployment on the UAT environment, followed by a manual approval step, which would then push it to production. The pull request pipeline just does the first bit of that. It does the jest test and the UI tests, and if those pass, then you can merge it into master to run the rest of it. And this worked pretty well. However, there was a problem with this. It's hard to preview a PR on a real device before merging. The tests are passing and you know it's working functionally, but designers want to get it in their hands, and they want to play with it and see how it feels and what it looks like, and like really inspect it. Now it's possible to upload this to a test device or to upload this to your developer device and show the designer or things like that, but this can be quite hard because it needs like a synchronous interaction to make that happen. And especially now that everyone's working from home, it's quite hard. You need an easy way for a designer to just get that PR on their phone and look at it, and you can just send them a message and they can have a look when you're ready for them to see it. So the challenge then was, we were thinking, what do other platforms do? And web apps specifically have solved this to an extent. Like they support deployment previews with hosting solutions like Netlify. Like when you raise a PR for your changes, you can go to a unique URL and look at those changes before they go live. And we drew inspiration from that, and we thought, is there a way we can replicate this with native apps? So the approach we came up with, like, since we're already using App Center and Code Push, this is a way of easily and quickly pushing out changes. Can we somehow leverage that to get this effect? So the approach we came up with is on GitHub, for each pull request, we push a bundle for that pull request to App Center, where the development app can access it. So it's only for the development app, not for the UAT or production apps. Those are separate apps in App Center. So we will walk you through the process of how we went about implementing that. The first step is, of course, to upload these builds as I just described. The way we did this with App Center, I don't know if you're familiar with App Center, it's got this idea of named deployments. For each PR, we create this named deployment, which is like a bucket for bundles of different versions of bundles. So you create a bucket with a name that matches the PR name, and you push on each PR. When you create the PR, you create that bucket, and then you push the new version to that deployment. And there's like the CLI command that we use to do that for people that are interested or familiar with App Center. But the effect of that is, like, if you go to the App Center interface, you can see there's a drop down of the branches, an example of what we've created. And for that selected branch, you can see multiple versions pushed to that named deployment as you do more updates to that PR. And these are then available through Code Push. This one extra bit of technical detail, like sometimes you do need to make native changes, which require like a full build that you can't just deploy through Code Push. We've got some logic around that and how we handle that. We see if the app version has been incremented. If it has been, we do a native build. And we've got some scripts to help you check, like if you've changed certain files, then it says like, okay, the app version should have been incremented. So it expects a native build in certain cases. This can lead to an edge case where you have two PRs both incrementing at the same time, and you end up with two new versions. And this can cause a conflict, but this is an edge case that we don't deal with automatically. You'll see two apps with the same version in App Center, and you'll just have to communicate with the designer or whoever to tell them which version they need to download, and eventually this will sort itself out. as you do more PRs and more version bumps. So after all of that, this is what the new master pipeline looked like for the PR. We just have the same master pipeline, but the updated pull request pipeline now matches the master pipeline more closely with the added development environment there. We do run all the tests, and if they pass, we do possibly a native deployment and a code push deployment on the PR.
Cool. So now we've got all of these named deployments in App Center for all of these pull requests that we're opening. So now how can we leverage those in our development app? So we want to be able to choose one of those deployments and get an automatic update, just like a deployment preview. So here's how we did that. So first we do a simple get to the App Center API. We get a list of all of the deployments which are created every single time we open up a pull request. So we've got that list. Then we're also going to want to fetch a bit more data. So from App Center, we also want the metadata about the current deployment name. So we're going to use that to display in our developer menu to say, this is the current update that you're looking at. And then we also want some extra data from our device info. So we want the current bundle version. So we're going to use that then to filter out the compatible builds. So we're going to compare the bundle version that we just got from device info and compare that to the minimum bundle version from our current update and see which are compatible and filter the rest out. So then whack some more buttons on there, and we've got this handy dandy developer menu. You can see under available versions there's some gibberish, which is our current deployment name. Should be named, it says UI fix jobs list header, so that was one of our branch names. And then you've got a menu of updates. So those are the filtered ones that you can press. So what's left? When you want to hit one of those buttons, what do you want to do? You want to download the update from App Center. You want to show some download progress, and then just restart the app for the user with the currently selected update. And then we've got a quick little demo. Kantan team is constantly growing, and they've got a never-ending list of features. So I'm seeing loads of pull requests, and I'm also seeing lots of frantic scrolling on that developer menu to try and find the feature that the design team actually want to look at. So we probably don't need all of those previews once the pull request has been merged and the branch has been deleted. So let's get rid of some of those. So what did we use? We used AWS Lambda, Terraform to automate the setup, and we used GitHub webhooks to trigger this action on the branch deletion. So what's the flow? So we've tested the feature in the developer app as we've been iterating, and now we're done. So here's the flow on branch deletion. We're going to merge a pull request, delete the branch. The GitHub webhook is going to pick that up on the branch deletion, and that's going to trigger a Lambda function. So all that's going to do is quite simple. It's just going to call the App Center API and delete the iOS and Android deployments for those given release names. And remember, we named all of our deployments with the branch name, so those are quite easy to find. And there you go. You've prevented all of that scrolling, and your developers are having a great time. So that seems quite involved. It was in the end. As of January, there are now GitHub actions for code push. So now you can do arbitrary actions with the App Center command line interface. So if you're going to try out this implementation, I would recommend looking into that implementation.
So in summary, we now have deployment previews. When you have the developer app, you can go to developer menu and you can see a list of all the different PRs that are open. You click on one and you can see what that looks like. And once you've looked at that and you've played around with it, you can see it working. You can merge to master confidently and frequently. And you know your designers and your product owner will be happy. So next steps, well, as we mentioned, GitHub Actions are now available for code push, and I think that would simplify things quite a lot. The Lambdas work well, but it's just unnecessary infrastructure that's part of the pipeline at the moment. I think GitHub Actions will make that quite nice and easy to maintain. Other potential things we were thinking of, well, improved pipeline performance, that's always something we're looking at. So anyone who has any good ideas on how to do that is always come have a chat with us. but it's always good to get it faster and get the feedback loop faster and faster on the pipeline. And then blue sky thinking, what if we added something like QR codes to download full builds? It would be nice if you could just, instead of having to go to App Center to find the best native version to preview this PR, if you just had a QR code you can scan, your phone automatically goes to the right native build that you can just download and then test it. So just things that will make the feedback loop faster and get people testing and seeing the features more quickly. Or any other ideas we could be thinking of after this. That's it. Thank you so much for listening and having a look at what we've done. And if you have any questions, come talk to us. Thanks.
You're live.
Hi, everyone. Thank you, Cam and Hentie, for that talk. That was really interesting on the deployment pipelines. So if anyone has any questions on that, please put the questions in the chat. But first of all, we've got a question from Mike saying, can you use App Center instead of TestFlight for distributing pre-release versions?
Yes. Well, internally we use App Center for distributing these versions, so we all use the App Center without being on TestFlight internally. If that answers your question.
I think that does. Did you ever consider doing multiple stages rather than just staging a pod, or was that not something you felt was necessary? And if so, how complex would that be to set up with your current setup?
Multiple stages, like going from to UAT to staging to prod.
Yeah, exactly.
We can do that easily. We just add, well, rinse and repeat, add more apps to App Center, and that's how we get more environments and just add it to the pipeline. There's a time cost to it though, because the pipeline runs quite slowly, running the native, the detox test and everything. So it does add up if you add too many stages to that, but it should be easy technically to add more.
So you had Detox Tests as part of your integration pipeline. How did you find that? And one of the questions I have is partly, did you manage to get that working with Android, or were they just on iOS?
Still focusing on iOS for now, just getting that smooth as possible. It is a work in progress. It's always a bit of a challenge. Don't think we've quite nailed it yet, but we try to focus on just having some basic tests to begin with, and then over time expanding it as we get those stable, making sure that we get a stable set of tests that we can expand over time.
Cool. And how did you find the actual naming as the branch naming for designers? Was that clear to them, or were they ever lost as to which build they should be doing on? Was that fine when you cleaned them up?
For the designers to find the correct builds in the developer menu to choose the correct app, it's not really been a problem. Most of them, we have a naming convention on the branches to have the Jira ticket number as a prefix in there, so they usually know which one to go with. But we also work very closely with the designers. We sit next to them, and we can just, well, when we're in the office, but we talk to them all the time. We just tell them which branch, which button to click on when they test it.
Right. So you mentioned also some other improvements for the future. Is there any of these that you're going to do shortly, or is there anything that's like right there as a checklist, or are you happy with it how it is right now?
Nothing in the immediate future. I mean, improving the performance of the pipeline is something we look at constantly. We recently did a few small things, but nothing huge and fundamental on that. The rest is a bit more long-term vision. Like this, right now is working really well. The GitHub Actions is something actually that we will look at sooner rather than later, I think.
Mm-hmm. And one thing you mentioned in the talk was the updates to native code, and the fact that you could have two PRs at the same time which should update to native code. How was it that you handled that?
I think the short answer is that we don't really handle it. It's because it's only for on dev, and it's for internal customers only. So when we do get in a situation where we have two PRs that both made native changes and we have this sort of conflict, That just has to be an internal conversation where we talk to the designer or whoever, say which version they should download from App Center and how they should work through that. But in our experience so far, it's been quite rare. Like usually people don't make native changes at the same time. Stories. Yeah.
Cool. Thank you very much for that talk, and hopefully we'll hear more again from you in the future if you ever update the pipeline or come up with something new and exciting. And thank you to everyone tonight for attending the meetup online. Hopefully we will see everyone else next month. Thanks.